Hello, my name is Dibjyoti Sarkar. Here we will be discussing about the following three programs. Uh, Actually, they are Arduino programs, and we will be writing Arduino programs for the following three filters. Like the first one is moving average filter, second one is derivative filter, also known as first order difference, and the third one is derivative filter. It is also known as 3-point central difference. Now we will be designing these three filters. We will be writing the programs, and we will check how this works and what will be the resultant outputs and the waveforms. So let's discuss about the first one, that is moving average filter. Here is already written the differential equation, that is yn equal to 1 upon L sigma k equal to 0 to L x of n minus k. From here only you can see that it is actually taking L inputs and it will give a single output which will be the average of those L inputs, and so it will be acting as a filter. Also we can say that this moving average filter is a low pass filter. Now let's come to that coding part. Okay, so first we can see that it's void setup. So for this setup we have to write the serial.begin 9600. Actually this means the operation rate of speed of that Arduino board. Okay, it is actually fixed for this, it is 9600. It's so we'll use serial.begin and in the bracket 9600, so it will operate at the rate of 9600 per second. Now we will apply loop. Like for this loop we will write float x, which is x is a variable here, and we have already received samples, like we have 125 samples. From there we have copied it and pasted it here. So these are the 125 samples, we have pasted it here directly. So again we will take like another variable which is y, and it will contain that all the 25 samples. So now if we apply, now we'll declare the variables in like integer I and j. Now again we will apply the for loop. Like for here for like we'll write the code as for int I equal to 0, I less than 25, I plus plus, which this line suggests that we are declaring a variable, this integer I equal to 0, which will be starting from 0 and it will be less than 125. So and this I will continue from 0 to 125, it will keep on continuing. So we can say that there are 125 values, so we know that the integers values start from 0, so it will have from 0 to 124, so the values will be 125 values. So here we'll again declare another variable sum, and we'll keep its initial value as 0. So suppose we take length of the moving average filter is 8, so we have declared a variable j. Now we'll use for loop for integer j equal to 0, it will start from 0 to 7, it will take, okay, from 0 to 7, 0 to j less than 8. So since j is an integer, it will take values from 0 to 7 and j will keep on continuing j plus plus. Then if I minus j is greater than or equal to 0, then the sum we have declared first as 0, then it will be equal to sum plus x of I minus j. So we know the equation of the derivative filter which we have studied. So it is the summation of all the inputs. So this is first we will take the summation. So this line is for the summation of the inputs. So again the final output which will be getting will be the like the average of the sum. Like so it will be sum it will keep on adding, and again it will be divided by 8. Since we have taken 8 filters, like length equal to 8, so it will be divided by 8, and this is for printing, like getting that waveform. So it's serial dot print xi. Okay, we have variable this xi, we have declared this variable for the sample points, then serial dot print, okay, and then serial content yi plus. So this will give the output of this moving average filter. So which we can check as, first we have to compile it, then we'll upload it, then it is showing the done uploading. So we can see the after by using the serial plotter we'll get the waveforms. So here we can see the required output waveform. You see there are many spikes, like there are many spikes here, but you see the spikes have reduced here, it has reduced, so the filter is working. Till now we have seen about the moving average filter. Now we'll look at first order differential, okay, filter. For like we have seen up to this part, like it will be the average of the inputs and it will give the output. Now like we know that the differential equation for the differential filter is like yi minus yi minus 1. Like if it is this, if this input is yi and yi minus 1, then it will be the difference of these two and it will be di. Suppose di I have mentioned here, di this d float d, this variable I have declared. So here I have declared this variable, so it will be the output. This yi is the output of this moving average filter. So this moving average filter's output we are giving as input to this differential filter. So rest is same. So just simply we are applying this code, then it will be serial.print again that thing, okay, and again it will be serial.print and serial.print ln di plus, it will give the output of the. So after this compiling and uploading, we can see the waveform like in the serial plotter. This will be in this way. So you see this is the input, this is the difference of the input minus input of the previous. So we'll get this required waveform. Now the last part is for the central difference. So 3-point central difference, and you can see from here that the differential equation is xn minus xn minus 2. So it is also derivative filter and it is called as, and this type of filter is known as 3-point central difference. So the difference equation is like this. So from here we can directly like know, you can write this code and we will get the required output. So you can write for I equal to 0, this is the value of this I equal to 0 to I less than 80, then it will be continuing, then this ci, this is the output of that 3-point central difference filter. Okay, then this is float c. I have like mentioned the variable. So after this it is xi minus xi minus 2. So I have simply written the difference equation, and after that this is for the same as thing for printing the outform. So if we compile it and then if we run it by using this done compiling, then upload it. After the uploading is done, we can go to tools and then again serial plotter. So from the serial plotter we will get this type of waveforms. So this will be the required type of waveforms. From this we have already now we have already designed 3 types of filters, that moving average filter, then first order difference filter, then 3-point central difference filter. So these 3 filters we have discussed in this 80 is we have taken actually 125 samples, but for clarification and that for smaller number of samples we have taken this as 80. So this, in this way we can find moving average filters and all those filters by this code. Thank you.